Hello, space-time followers. Today, we're embarking on a journey to the mysterious world of Mars. We all know Mars for its red color, massive canyons, and volcanoes. But did you know that the lack of a core in Mars's interior affects the planet's gravity and surface movements? Yes, the absence of a core in Mars not only impacts its interior, but also deeply affects its surface. Understanding this helps us glean insights into Mars's past and is crucial for future explorations and manned missions. Let's dive into the underlying factors of Mars's gravity and surface movements. Ready? Let's get started. So, what do we know about Mars's gravity? Mars's gravity is significantly weaker compared to Earth's. On Earth, your weight is what it is, but on Mars, you'd weigh about a third of that. For instance, if you weigh 60 kilograms on Earth, you'd weigh roughly 20 kilograms on Mars. Walking on Mars with this lighter feeling would certainly be a unique experience. Now, why is Mars's gravity so weak? One of the main reasons is the absence of a solid core. Unlike Earth, Mars doesn't have a solid core, which affects the planet's density and consequently its gravity. The lack of a core results in Mars having a weaker gravitational force. Mars's gravity not only affects how you walk, but also influences the planet's surface features and atmosphere. Lower gravity makes it easier for dust and sand on the surface to move around. Additionally, it makes the atmosphere thinner and more vulnerable. Hence, Mars is known for its strong winds and massive dust storms. At this point, understanding how Mars's gravity interacts with other planetary features is vital for assessing its potential for life in future manned missions. Gravity is one of the primary forces shaping the planet's surface, and its absence on Mars brings many mysteries and questions. Mars is a planet with many fascinating geological activities on its surface. However, understanding how these activities differ due to Mars's lack of a core is truly intriguing. Earthquakes and volcanic activities on Earth are mainly caused by our planet's hot and active core. So, what about Mars? Mars also experiences tremors, known as Marsquakes. However, these are much weaker and rarer compared to those on Earth. The reason is the lack of sufficient heat in Mars's core and the significant cooling of the planet's interior. Therefore, the tremors on Mars usually result from large cracks and stresses on the surface. The absence of a core also affects Mars's volcanic activities. The largest volcano on Mars, Olympus Mons, holds the record for the biggest volcano in the solar system. One reason this enormous volcano is so large is that Mars's interior lacks sufficient heat and pressure, making it easier for lava to reach the surface. This results in large but less active volcanoes. Mars's surface also features vast canyons and craters, which hold important clues to the planet's geological history. The stresses and surface movements caused by the lack of a core contribute to the formation of these massive structures. In conclusion, the absence of a core in Mars directly influences all the movements and formations we see on the planet's surface. This is a critical factor in understanding Mars's geological history and planning future explorations. Now, let's delve deeper into Mars's volcanic activity. Volcanoes and volcanic activities play a significant role in shaping Mars's surface. Understanding Mars's volcanic past is crucial for grasping both its surface appearance and geological history. Exploring how volcanic activities are related to the absence of a core is an exciting topic. First, let's talk about the most prominent volcano on Mars, Olympus Mons. Standing at about 22 kilometers high, Olympus Mons is nearly 3 times the height of Mount Everest, making it the largest volcano in the solar system. The absence of a core, resulting in a cooler interior, is one reason this massive volcano is so large. Lava finds it easier to reach the surface on Mars, leading to large, expansive volcanoes. Mars also has many other large volcanoes and volcanic regions. The Tharsis region is a significant volcanic plateau on Mars's surface. This area is crucial for understanding how changes in the planet's interior and the absence of a core affect volcanic activity. Lava flows and traces of ancient volcanic eruptions are evident in the Tharsis region. However, volcanic activities on Mars are not as frequent and active as on Earth. The absence of a core and the cold interior make volcanic activities rarer and weaker. This suggests that Mars's volcanic past largely ended long ago. Nonetheless, volcanic traces on the surface indicate that the planet had a very active volcanic period in the past. Volcanic activities also influenced Mars's atmosphere and surface. Volcanic eruptions released large amounts of gas and dust into Mars's atmosphere, altering the planet's climate and surface conditions. These changes provide important clues about whether Mars had water in the past. In conclusion, volcanic activities on Mars are directly related to the absence of a core, which is crucial for understanding the planet's geological history. Now, let's explore the surface features of Mars and how the absence of a core affects these features in more detail. Mars's surface is filled with vast canyons, deep craters, and massive volcanic structures. Understanding these surface features and how the absence of a core affects them is critical for grasping Mars's geological history. Let's start with the massive canyon known as Valles Marineris. This canyon is the largest canyon system in the solar system, stretching about 4,000 kilometers long, 200 kilometers wide, and 7 kilometers deep. Understanding how Valles Marineris formed helps us comprehend how stresses on Mars's surface operate due to the absence of a core. The lack of a core prevents Mars from retaining sufficient heat in its interior, causing the surface to cool more quickly. This leads to the formation of large cracks and canyons. The craters on Mars are also affected by the absence of a core. Impact craters are commonly seen on the planet's surface, and Mars's thin atmosphere allows large meteors to create deep and wide craters when they strike the surface. The lack of a core means Mars generates less of a magnetic field, causing the atmosphere to thin over time. A thin atmosphere makes Mars more vulnerable to meteor impacts, increasing the number of craters. Mars's surface features also include dried riverbeds and deltas, which provide strong evidence that Mars once had water. The absence of a core and the planet's cooling could have made it difficult for water sources to remain stable on the surface. As a result, water that once flowed on the surface likely evaporated or froze over time. Lastly, the glaciers and ice caps found in Mars's polar regions are also affected by the absence of a core. These glaciers provide important information about the planet's climate and surface features. The lack of a core weakens Mars's magnetic field, causing the planet to be continuously bombarded by solar winds and cosmic radiation. This results in the melting and refreezing of polar glaciers, affecting the surface features. Understanding how Mars's surface features relate to the absence of a core helps us better understand the planet's geological history and the importance of future research. Now let's look at how future research and missions to Mars can provide more information on this topic. Understanding Mars's interior structure and the effects of the absence of a core is of great importance for future research and missions. These studies not only provide more insights into Mars's geological history, but also offer critical data for manned missions and colonization projects. NASA and other space agencies are planning various missions to better understand Mars's interior structure and the absence of a core. One of the most important missions is the InSight mission, designed to study Mars's interior. InSight uses seismometers and other instruments placed on Mars's surface to investigate the planet's interior structure and tremors, examining the effects of the absence of a core on the surface. This data helps us understand Mars's geological history and how surface movements occur. Additionally, manned missions to Mars can provide more information about the absence of a core. Future Mars missions will investigate how Mars's gravity and surface conditions affect human life. Long-term stays on Mars offer a direct opportunity to observe the effects of the absence of a core on gravity. These observations will aid in developing plans for permanent settlements and colonies on Mars. Another important goal of future research on Mars is to examine the planet's surface features and atmosphere in more detail. These studies will provide more information about Mars's geological past and the presence of water. The canyons, craters, and dried riverbeds on Mars's surface will be examined in more detail in future missions, yielding more data on these structures. In conclusion, understanding Mars's core absence and its effects on the planet is crucial not only for scientific research, but also for future manned missions and colonization projects. Better understanding Mars's interior structure and surface movements will help us grasp the planet's geological history and determine whether life is possible on Mars. Understanding whether life is possible on Mars and how suitable the planet is for manned missions and colonization is a significant part of future space research. The absence of a core in Mars has substantial effects on gravity and surface movements, directly impacting future manned missions and colonization projects. Mars's low gravity can have serious effects on the human body. Our bodies, accustomed to Earth's gravity, may lose muscle and bone density in Mars's lower gravity. This can cause health problems in long-term Mars missions. However, low gravity also offers some advantages. Heavy equipment and structures become easier to transport and construct. Surface movements on Mars are also an important factor for colonization projects. Mars frequently experiences large dust storms, which can pose a significant threat to surface structures and equipment. Additionally, tremors, Marsquakes, and surface shifts are observed on Mars. Although these surface movements are weaker and less frequent due to the absence of a core, they are still significant factors to consider in colonization projects. The absence of a core in Mars results in a weak magnetic field and a thin atmosphere, leaving the planet's surface exposed to harmful solar and cosmic radiation. Humans living on Mars will need special protective structures and clothing to shield against this radiation. Moreover, building colonies may require solutions such as underground structures or thick protective layers. Despite these challenges, life and colonization on Mars are still possible. While the absence of a core makes it difficult to maintain stable water sources on the surface, water can be found in the polar regions and underground reservoirs. These water sources can be used for agriculture and water supply on Mars. Additionally, advancements in biotechnology and genetic engineering may help humans adapt to Mars's gravity and surface conditions. A successful colonization project on Mars will require innovative and creative solutions to overcome the challenges posed by the absence of a core. The knowledge and experiences gained in this process will be important not only for Mars, but also for making life possible on other planets and even distant star systems. In conclusion, the absence of a core in Mars significantly affects gravity and surface movements, and this is a crucial factor to consider for manned missions and colonization projects. Future Mars missions will provide important information to overcome these challenges and make life on Mars possible. Mars, known as the Red Planet, becomes even more exciting to explore due to its internal mysteries and the absence of a core. The lack of a core in Mars significantly impacts the planet's gravity, surface movements, and geological features. This is of great importance for both scientific research and future manned missions and colonization projects. Mars's low gravity makes moving and walking on the planet easier, but prolonged exposure can have adverse effects on human health. Therefore, new solutions need to be developed to maintain the physical health of humans living on Mars. Surface movements and geological activities on Mars differ from those on Earth due to the planet's lack of a core. Large volcanoes, deep canyons, and wide craters are prominent on Mars's surface and provide insights into the planet's past geological activities. However, these features also present challenges that must be addressed in future colonization projects. The weak magnetic field and thin atmosphere on Mars, resulting from the absence of a core, leave the planet's surface vulnerable to radiation. This necessitates the development of special protective structures and technologies for long-term living on Mars. Despite these challenges, Mars's water resources and other natural features offer promising prospects for colonization. In conclusion, the absence of a core in Mars significantly affects the planet's gravity and surface movements. Understanding these effects is crucial not only for comprehending Mars's geological history, but also for future manned missions and colonization projects. Overcoming these challenges and developing innovative solutions to make life on Mars possible will be a significant step for humanity's future in space. Thank you for joining us on this mysterious journey, space-time followers. We've learned a lot about the absence of a core in Mars and its effects on the planet. If you're interested in more intriguing topics like this, don't forget to subscribe to our channel. Also, hit the notification bell to get notified about our new videos immediately. We look forward to your comments and questions. Until our next exploration, take care and keep your eyes on the stars.